Okay, now the cluster is created with the name test cluster, and also the metadata about the cluster is saved under this location. Okay, so first of all, let's check if we have the metadata about this cluster here. So for that, what we can do is we can say cat that location. So if you do this, so this is going to contain the authentication mechanism and also the details about this cluster, right? So that looks good. Let's clear this out and let's go back to AWS console and see if we have these worker nodes created. Let me refresh this and we can see this, we have 3 worker nodes created. Okay, and if we go back to EKS and see here, so also this status is active. So that means we can now deploy our applications to this cluster. Okay, so before that, let's go back here and then, okay, now we need to deploy our application to this cluster, right? So how do we do that? So before that, so we're gonna run the manifest files, okay, the same like we did for creating our cluster. We're gonna do that for our for deploying our microservices. Okay, so the manifest file for deploying microservices is Kubernetes manifest.yaml file. Okay, so I got this file from the, let me take you back there. Okay, the Google Cloud Platform microservices demo application. I went ahead and checked this release folder, and within that folder they have this file. Okay, so this is the manifest file for deploying all these microservices. Okay, we're gonna take a quick look at how things are working here, but I have already copied this into my repository, so we have everything that is needed under my repository, so we don't have to go back and check on other repositories. Okay, so I have already copied it here, and then since we have opened this repository in our local computer in VS Code, we can check here as well. Okay, so this is the one, Kubernetes manifest.yaml file. Okay, let me expand this a little bit. Now if you see here, so there is a lot of Kubernetes objects. Okay, if you see here, so this is triple dash, so this is basically separating one Kubernetes object from the other. Okay, so if you see here, this is a deployment kind of Kubernetes object, and the metadata about this deployment object, and also these selectors. So basically these selectors, and this is going to be you know, the services is going to use this metadata to select this deployment. Okay, and under the template, so this is where you specify your details about your container or the pod. Okay, now here if you see here container, the details for containers are here, and then the image, under the image section, let's minimize this. Under the image section, if you see here, so this is where, this is the Docker image. Okay, so this is where it's gonna pull this Docker image for email service. Right, so similarly we have all this deployment and service for each of these deployments. Okay, and one thing, let's search here something called load balancer. If you see here, now here, so this load balancer, so this is a service of type load balancer, and this is actually configured for front-end service. Okay, this front-end external is our front-end application, so that is actually exposed with the service type of load balancer. Okay, let's go back here and understand it a little more. Okay, let's go back to this GCP repository here. Now if you see here, so there is something called front-end, right? So this is actually exposed using a load balancer. So that means it's going to connect to the cloud load balancer, and if we make a request to that IP, we can actually make call to this front-end application, and internally this front-end is going to talk to respective microservices. Okay, that's what we're going to do. But before we do that, we need to deploy our microservices. Okay, now for deploying, we just need to apply this file, okay, in the cluster. So now that we have our cluster ready, let's go back here and do ls. Okay, we already have this file here, Kubernetes manifest file.yaml, right? Now if you okay, before that we need to also verify that we have our worker nodes created. We verified that from this AWS console, because when you do ec2, and then if you go and see the instances, we already have 3 instances running, right? So that means 3 worker nodes are running. You can also check that from here. So kubectl get nodes, right? If you, sorry, kubectl cube. Okay, when you do kubectl get nodes, so you're gonna get this each of these worker nodes and their IPs. Okay, now, and also the age. So this has been up and running since last 10 minutes. Okay, now that we have our EKS cluster ready, we have our worker nodes already running, we can apply this Kubernetes manifest file to create deployments. Okay, now let's do kubectl. Now before that, let's understand how do you apply this and all that. Okay, let's go back to this here and see some hands-on practices. Okay, now so we did kubectl get nodes, and this already displayed this nodes for us. We already did this. Okay, let's go back here and understand a little bit about Kubernetes manifest files. Okay, which we already saw, but let's see the theory. So Kubernetes manifest files is basically the YAML file that we already saw, that defines the desired state of Kubernetes objects such as deployments, services, pods, config maps, and things like that, or other Kubernetes objects or resources. Okay, now these files describe how these objects should be configured, deployed, and managed by the Kubernetes system. Okay, now let's go back here again. Now by applying this manifest file, you instruct Kubernetes to create or update resources according to the specification in the file. Okay, so how do we apply these files? We say kubectl apply -f and then the name of the file, okay, or the location of the file. So after we apply this, then we can check if the pods are created, if the services are created, if there is any namespace created, and if you want to delete this, we can do kubectl delete. If you want to inspect, we can do kubectl inspect and things like that. Okay, so these are the commonly used kubectl commands. Okay, so let's go back here and then let's apply the manifest file. Okay, first of all, let me do kubectl get pods. So in Kubernetes, you can do either get pods, or you can also do get po. That's the short form for pods. Okay, so if I do get pods, so there is no resources found in the default namespace. Okay, so like I mentioned earlier, if you do not create any namespace, so you're going to have something called default namespace. Okay, and if you do not specify the namespace, so when I say kubectl get pods, so this is equivalent to saying default. Okay, so give me all the pods that are in the default namespace. Okay, so this is equivalent to saying this, right? So let's press that, it's going to give me the same thing, right? So no resources found in the default namespace. Now let's apply this and see if the resources are going to be created. Okay, let's clear this out first of all. Now I'm going to do ls. So this is the file we want to apply. Okay, so this file has all the details which we already saw here. Let me close this down here, and also let me show you one thing here, something called replicas. See here, replicas. Okay, so for each of these services, we're actually running one instance. So replicas equals to 1. That means we have one service running for one instance running for each of these services. Okay, so let's go back to the terminal again, and then kubectl apply -f and Kubernetes manifest.yaml. Okay, now as soon as I press enter, this is going to create all the deployment and services. Okay, now let's go back here and see. So deployment email service created, and then service email service created. Okay, and then we have service account for email service created. Then the same thing for checkout, service for checkout, and then service account for checkout. Okay, the same thing is happening for all these microservices. Okay, now if we do, so these are all, so since we didn't specify the namespace, these are all going to be created under the default namespace. So if we do kubectl get pods like before in the default namespace, or since this is a default namespace, we don't even need to specify that. We can simply say kubectl get pods. Now this is going to show us all the pods, and these are all in the running state. So 1 out of 1 pod is running, and then this has been running since last 47 seconds. And if you check here, so this one is still initializing, it's not in the running state. Now we can query again, and then now we can see all these pods are in the running state. Okay, all these pods are ready to accept the request or serve the request. Okay, now so we just checked the pods. Okay, now let's see how to check. Let's clear this out, and let's see how you can check the services. Okay, now let's do kubectl get svc. So this is the short form for services. Okay, now don't specify the namespace, or you can specify -n default. Okay, now let's see how many services are there in the default namespace. Okay, so these are all the services that are in the default namespace. Okay, so this is add service, cart service, and currency service, checkout service, and all the other services. But if you see here, these services are exposed as cluster IPs. Okay, so this is one of this Kubernetes service type called cluster IPs. But front and external, so this is the front end application that is exposed as load balancer. And like I mentioned earlier, so this is going to expose a load balancer, and we can actually access this IP in order to connect to our front end application. Okay, let's try this out. I'm just going to copy this command, this URL, the load balancer URL, and then let's go back to the browser and then paste it there and then enter. Okay, if everything is working, we should be able to access this application just like this. Okay, so this is basically an online boutique application. So this is the same application. Okay, so provided by the Google Cloud Platform. Now you can open this, you can select and then add to cart. You can place order, you can continue shopping and things like this. Okay, so this is the application that is running here. Now this is so it is this simple to get this application running once you have your manifest files written correctly. Okay, now two main things. Okay, let me take you back to these slides here. Okay, so we already know how do you get these parts. Also we can do get namespace. Okay, let's try for get namespace. So if you do kubectl get ns, that is short form for namespace. Okay, so if you do that, you have default namespace. So that's the only namespace. And then there are these 3 namespaces are available by default. We didn't create this. Also, we didn't create the default. So these are all available when we create the cluster. Okay. So later on, when we discuss about service mesh, we're going to create our own namespace as well. Okay. Just to make things clear, I just wanted to show the namespaces also. All right. So that's it. And then if you want to inspect what's happening in each pod, you can do kubectl inspect pod and then pod name. Okay, let's try this one. All right, let's clear this out. Then you can do kubectl get po, that's a sort for pods, and then you can copy one of these pods. Okay, let's copy one of these front end apps. Okay, let's copy this one, and what we can do is you can do kubectl inspect pod and then the name of the pod, right? Inspect pod. Okay, something's wrong there. Inspect pod and pod name. Let's see. Inspect is not available. Okay, we can check this online real quick. Let's see. Inspect pods. kubectl. Let's see here. Inspect PO, and then yeah, it's working for them, right? Let's try it out for other services. Something's wrong. Kubectl inspect pod and the name of the pod, right? Okay, let's try this out for this service here. Kubectl inspect pod or can just say PO and then this one. Okay, inspect is not defined. Let's see here. Okay, it's working for this guys here, but not for some reason it's not working. Inspect PO. Okay, maybe we need to, is it because we didn't specify the inspect pod and my pod, right? They're actually doing the same thing, but it's not working here. All right, not a problem. Okay, I can come back to this later. I'll check it and I'll update in this video. Now, okay, another thing that, okay, let me take you back to the slide and talk a little bit more about what we have next. Okay, so we already discussed about this and we already did this. Now, how do you scale applications up, right? Now, so this is the command for deploying, sorry, scaling up, not scaling, microservices deployment. Now scaling up, so this is how you scale your microservices, right? Now let's say get deployments. Okay, let's do kubectl get deployments, or you can simply say get deploy. Okay, so these are all the deployments that we have. Okay, so now we can actually scale up one of these deployments. Okay, let's scale up this card service, for example. Okay, how do you do this? So for that, you need to do kubectl scale deployment and then the name of the deployment, then -- replicas equals to 3. Okay, as of now, only one instance of this deployment is running, right? Now, how do you scale this up? Let's see. Let's do kubectl scale deployment, or you can say scale deploy and the name of the service. Sorry, what was the name of the service? Card service, and then -- replicas equals to 3. Okay, if we do this, now this is saying that this card service is scaled. Okay, now if we do, let's clear this out. Now if we do get deploy, now this is going to create 3 deployments. Okay, so out of which one is ready. Then if we keep querying, so this is going to be like 3 out of 3. Okay, so this is going to take some time. Now if we go back and say kubectl get parts, okay, now if you say get parts, you can see 3 parts for card service. Initially we had just 1 part. Since we scaled to 3, so it's gonna create 2 more pods here. So if you see here, the age of this first and the last one is 32 seconds, right? So it's going to create 2 more pods, right? So that is the idea. Now here, if we go here and check get deploy, now this is showing 3 out of 3, right? So this is how you scale up. Now if you want to scale it down, pretty simple. So you just specify the replicas equals to 1. Okay, now if you do this, it's gonna scale it down to 1. Okay, how do you verify this? You can just go to kubectl get deploy. Initially this card service was 3 out of 3, right? Now card service is 1 out of 1, and if we check the pods as well, let's see, now the card service has only 1 instance, right? Initially it had 3 instances, right? So these are the 2 important now this is one important feature of Kubernetes, the scalability. Okay, so this will help us how we can scale up or scale down these services. Okay, so that's one feature. Now let's talk about another feature that's called auto healing. Okay, now auto healing is in case of something that goes wrong in the pod. Let's say one pod crashes. Now since we have specified replica set as 1, let's go back here. Okay, if you see here, the replicas is 1. So this means at any given time there should be at least 1 instance of the service running. Okay, there should be at least 1 pod running at any time. Okay, now let's say something went wrong for some pod, let's say card service. Okay, then Kubernetes is going to automatically create another instance or another pod and then assign a new IP to that. Okay, let's do one thing here. Okay, let's to mimic that something is wrong, something went wrong in the pod, let's delete that pod and see if it's going to create automatically. Okay, let's do clear. Now we can do something like okay, kubectl get po hyphen o white. Okay, if we do this, so this is going to get pods and the output wide. Okay, so wide output is also going to give us the IP of the pod. Okay, so this is the pod and then IP for that pod. So like I mentioned earlier, each pod is going to have an IP assigned to it. Okay, now let's see here, card service. Okay, if you see card service, and this has an IP 192.168.47.15, right? Now I'm going to delete this pod called card service. Okay, once I delete this pod called card service, it's going to delete this one, the existing pod, and then it's going to create a new pod and assign a different IP. Okay, let's check that out, right? So how do you do this? Kubectl, sorry, delete pod, and then the name of the pod. Okay, what is the name of the pod? It's card service. Okay, let's go back here and then paste it. Okay, now the card service is deleted, right? Now even if we delete, let's go back and see kubectl get pod, sorry, kubectl get pods, right? Get pod. See, this is creating. This is actually 0 out of 1, but it's actually creating. If we do multiple runs here, we should be able to see 1 out of 1. Okay, now let's do it again. Okay, there it is. So just deleted card service, but it created a new one. How do we verify that a new one is created? We can check the IP of that, right? So let's go back and check the IP with -o wide. So the output is going to be wide. Now see here, the card service has a different IP. So initially it has 151 at the end. Now it has a different IP. Okay, so this is called the auto healing feature of Kubernetes. Okay, so these are the two major features that I wanted to demo, but there are more features of Kubernetes. There is so much more you can do with Kubernetes, and in the next part I'm going to talk about service mesh. But if you want to learn more about Kubernetes services and objects, you can go back and check this document again. Okay,